Hey class, this is the third video for our ionic bonding chapter, and it's going to be over polyatomic ions and polyatomic ion compounds. The word polyatomic tells you exactly what it is. Poly, meaning many, and then atoms is what atomic stands for. So an ion made of many atoms of different elements. So instead of having things like just barium, just nitrogen, just sulfur, you have things like phosphate, chlorate, sulfate, nitrate, etc. Now, these ions as a total have a charge, not the individual elements. So NO3 for nitrate has a -1 charge. The oxygen is not what has that charge. It's the whole ion. And that's where the confusion sometimes happens. If you see an 8, ATE at the end of it, nitrate, carbonate, phosphate, that just means it's an element with a bunch of oxygens. Same thing goes for an ite. If you see ITE at the end of a polyatomic compound, you know it's an element with a bunch of oxygens, but one less. Nitrate is NO3, nitrite is NO2, but they both have the same -1 charge. And this may sound confusing at first, but we're going to ease into it because this is a tough concept. You won't have to memorize any of these aside from maybe a couple that you need to memorize, because on the back side of the periodic table, you will find a list of all the common polyatomic ions. I have put a copy of the back side of the table in the first module for this unit. That way you can reference it, download it, have it for your use on any kind of homework or any kind of assignment throughout the rest of the year, basically. Let's take a look at a couple of examples. All right, this first part wants us to write the formula for a polyatomic compound. Now, you're going to need your periodic table when you're doing these. Even after doing this for so many years, I still get a couple of them mixed up. So just in case, there's mine. The process is exactly the same for writing the formula as it was for binaries, except this time we have polyatomics instead. Oh, and the polyatomics are always going to be in place of the nonmetal, except for ammonium. That's the only one that can be in place of a metal because it's the only positive charged polyatomic. So sodium chromate. First up, write your formulas. Sodium is Na, and it's a 1+. And then chromate is CrO4. And that's the polyatomic. The ion portion is a 2-. Again, that's not the oxygen that's charged, that's the whole thing. CrO4 has a charge of 2-. Now, you do the same thing, crisscross applesauce. That goes to there, that goes to there, and then rewrite your formula. So Na 2, CrO4, remember that's one thing, CrO4, 1. So we're good, 1. You just write CrO4, that's 1 unit, that's 1 polyatomic ion. Okay, let's go to another one. Magnesium nitrate. Write magnesium out, Mg, and it's a 2+. And then nitrate is NO3, 1 minus. So that whole compound has a 1 minus charge. We'll learn later those are covalently bonded compounds that have a charge. But don't worry about that right now. Crisscross applesauce. We end up with Mg1. Don't have to write the 1. NO3, 2. Now, we can't write NO3, 32. That's not correct. But we also can't write a 2 here and a 2 there. So, to designate that we have 2 nitrates, we put that in parentheses and then put our 2 outside of the parentheses. So anytime there's a polyatomic with just 1 molecule, leave it alone. If it's more than 1, it has to have parentheses around it, and then the subscript goes outside the parentheses. Okay, let's look at lithium phosphate. Lithium is a 1+ cation. Phosphate is PO4, 3 negative. Crisscross applesauce. And you end up with Li3, PO4, 1, no parentheses needed, PO4. Okay, let's check out number 6, ammonium chloride. This is the one example, the one exception where you can have a polyatomic as your cation. Ammonium is NH4, and it has a 1+ charge. Chloride, we know, is just chlorine, Cl. And chlorine's in group 7A, so it has 7 valence electrons. It needs 1 more, so it's going to be 1 minus. When we got 1s up here, we get 1s after we crisscross, and we end up with just NH4Cl. Okay, last one, barium acetate. Barium is Ba, and it's in group 2, so it's going to have a 2+. Acetate, as you'll see, can be written multiple ways, but I like to write it C2H3O2. So we got 3 elements covalently bonded to form that ion. And it has a -1 charge. So, crisscross applesauce, you end up with Ba1. Don't have to write the 1. We're going to have 2 acetates, so we know we need to put parentheses. C2H3O2, and then don't forget our 2 outside of the parentheses. Same procedure, same process as with binaries, except you got to make sure you don't get confused as to what the whole charge is, and then don't forget the parentheses. Let's look at naming, and I have a feeling you'll like naming much more than formulating. All right, KCH3CO2. That's one of those weird ways they can write acetate. So I'm just going to put acetate right here. All you do is name the metal and then name the polyatomic. Potassium, that's not how you spell potassium. Potassium acetate. Simple as that. Next one. Mg3PO42, magnesium, PO42, what's P? Phosphorus, phosphate. And again, you don't even have to memorize these. Just look at the back of your periodic table. Let's see. AlClO3, 3. Al is aluminum. ClO3 is chlorate. How about NaNO3, sodium, NO3, nitrate. No oxidation numbers, no charges, no crisscrossing. Just write the name of the metal, write the name of the polyatomic, except one exception. This one right here, NH4OH. What's NH4? Ammonium and then that's not one element, that's two. OH is that other polyatomic that you need to commit to memory. Ammonium is one, OH, hydroxide is the other. You'll see these very, very often, especially hydroxide. So get in the habit of recognizing OH minus, because it's a -1. Get in the habit of recognizing that as hydroxide. And let's see, here one more. CaSO4, calcium. We hadn't had the S yet. Sulfur, so sulfate. Simple as that. Again, this is going to be kind of difficult to get the hang of, but once you get it, you'll think, why did I ever struggle with this? And don't be afraid to ask questions, because this is the kind of stuff every year that questions start to come up, and students that don't ask those questions start to struggle. So let me know if you have any problems with this.